are commonly used in the kind of work that we do.
Okay, now this is, as you say, it's in mice, and it's a really significant development in early embryology. With these types of stories, the press sometimes gets a little bit breathless about the coverage and does make the speculative leap to humans. The Daily Mail headline was quite shocking. It suggested that this is a technique that possibly made women redundant in having babies. How do you feel about your work being reported like that? How true are those sorts of headlines?
One of the problems with our imagination is, I mean, it depends I think it depends partly what it's based on. We know incredibly little about what happens to the sperm and the egg in the moments after they've combined together in fertilization. So we know incredibly little, and of course we can imagine all sorts of things, and you can probably imagine taking a cell one day in the distant future and doing something to it, and it just right there in a dish in front of your eyes is starting to develop like an embryo and that could develop fully. We can imagine these things, but actually on what is our imagination based? That's the question.
But one of the more obvious potential applications of this type of technique is for conservation, I think. It's looking at the preservation of endangered species. Is this something you might envisage?
Well, the same technical barriers apply in the end. The reason that this kind of technology would be particularly interesting to conservationists is because you don't need an egg, and of course in many endangered species it's very, very difficult to obtain an egg, and if you could use a different cell, maybe from an animal that was recently dead, so you know, you could imagine that people would want to take cells perhaps from endangered species and combine them with sperm in this way and see whether they could obtain offspring, but the same technical hurdles are there. I'm sure people will be working, not just ourselves, to sort of chip away, in our case, to try and understand or use this system to understand what happens in natural fertilization, and who knows where it will lead. Perhaps it will lead to some of these things that we've been talking about.
Tony Perry from the University of Bath. Now, next week's BBC Inside Science is a special edition exploring the unknown, from deep space to deep oceans via other worlds. My guests will be explorers of space, the sea and planets, astronaut Tim Peake, oceanographer Helen Chersky and astrobiologist Zita Martins. We're recording it at New Scientist Live, a science festival in London next Thursday, that's the 22nd. The recording is at 12:30 and will be on air at the normal time of 4:30, but why not join us in the audience with a chance to put your questions to our guests? Details of how to reserve a place are on our website. But before we get there, we journey into deep space right now. The spaceship Gaia launched in 2013. Its 5-year mission to boldly film, well, pretty much everything in the night sky. It's up there to capture images and create the most accurate 3D map of the Milky Way ever, and in doing so answer questions about dark matter, how the Milky Way formed, test general relativity, you know, generally sciencing the galaxy. Anyway, yesterday we got back Gaia's first data dump that contains mysteries yet unexplored and new information on more than 1 billion stars. Jerry Gilmore from Cambridge University is the mission chief, and earlier I asked him what Gaia has been up to in its first 1,000 days in space.
It has spent almost all of the time, apart from 3 weeks, 1.5 million kilometres away from the Earth, following the Earth around. So it's been around the Sun a couple of times. It's recognised because it's always due south at midnight on the equator every night.
So it's locked to the Earth's orbit?
That's correct, yes.
And what's it pointing at?
It's spinning. It points exactly at 45 degrees from the Sun. That's the thing that's fixed, so that there's a big sun shield, half the size of a tennis court. The payload is in cold, dark shadow, and the spacecraft is spinning. And so every 6 hours it does one rotation and does a scan around the complete sky, and then slowly, as the spacecraft follows the Earth around the Sun, that scan maps out the entire sky. So every 6 months it covers the entire sky.
It's it's your description, not mine, because it sounds a little bit derogatory, but it's basically a cup and saucer, right? So the structure of the ship looks a bit like a teacup.
It's deliberately designed to be as simple as it can possibly be, and that's because it is the most high precision, most stable, most technically precise thing ever built by a huge margin. It is astonishing. But to put that in a sort of real number, the spacecraft flexes very slightly every 6 hours. There's a little bit of heat from the sun causes it to flex a little bit, but the structure is 4 meters across, 2 meters high, And the amount by which it flexes, which is a number we calibrate very accurately, is the same as 1/10 of the size of one molecule.
Or
So
you can even measure
that's a huge
that level of flex.
Yeah, that's a huge signal for us. So that's enormous, and so we can measure it very, very accurately indeed. But it just gives you some idea of what an exquisite piece of space hardware this thing is.
Well, now I feel bad that I described it as a cup and saucer. What's it been recording?
Well, the heart of Gaia, apart from the two telescopes hanging on the structure, they both feed one gigantic camera, biggest camera ever built and put into space. It's a 1 billion pixel camera. But essentially it sends down continuously a high definition movie of the sky to us.
Movies. It's not taking still shots.
No, it's a movie.
That is a lot of data.
It is, yes. It's a very large amount of data.
We covered New Horizons quite a lot over the last year, and that had something like 4 gigabytes of memory, and
yeah, we run through 4 gigabytes in about a millisecond.
Well, that's astonishing. Well, and what is it looking at as it's recording?
It's everything. Actually, it just images everything. That's the key point. There's no bias. There's no preconception. 2 telescopes feeding whatever they see onto this gigantic camera, which records everything and sends it down to us. So we get a complete picture of the sky. That means we not only record all the stuff that's always there, like stars and galaxies and so on, we also record stuff that comes and goes, like asteroids or transients, like supernovae, exploding stars, stuff that wasn't there an hour ago, we'll find the next time we look.
It strikes me that that level of data harvesting, the real bottleneck in getting the science out there is actually processing that. I mean, surely you've got much more data than you know what to do with.
There's a lot of data. We've got a lot of computers, big computers as well. The data that was released today, this morning, includes over 700 billion measurements.
Right.
But
get to work on
that's
that.
A lot. Yeah, it's right. Well, if you remember, just to put that in, I mean, who knows what a billion is? Astronomy numbers, they're stupid. But if we looked at a billion of anything and we spent 1 second looking at each one, we would get the billion done in 30 years. So that's a billion is a big number, right? So what you could do in your life. We've got billions upon billions of these things, and we don't have billions upon billions of people. So you need clever computers. But the other thing this leads to, a unique thing never done before in any mission, is as soon as the data are in a fit state to do anything with, we release them free to the entire world. So most missions, you go off to a planet or something, the people who lead the mission get the data and they keep it and they analyse it for a year or two, and then they publish whatever's left for the rest of the world to do something with. We have the exact opposite philosophy. So we know there is just such an enormous scientific bounty sitting in there, and there's such a large volume that it'd be just pointless and inefficient to try and do it all ourselves. So we do the other extreme and we release the whole lot.
How do people get involved? How do the listeners actually contribute to this astonishing project?
Well, there's 2 ways. You can, if you're a sort of computer nerd, you can go to the website and download the data and try and make some sense of it, but that's not an easy thing to do. More directly for normal humans is to go to our website, which is gaia.ac.uk, and this is where we publish every day our new discoveries, like the transients and the supernovae and the things that go bump in the night that we don't know what they are. And there's a program there that allows school classes to sign up to follow them up.
It sounds like you and many other astronomers have got their work cut out for them for many careers to come. Is this the new model? Is this how we're going to do astronomy in the future?
Well, Gaia's pretty special because it is the first ever big survey of where things are and how they're moving. And so whenever you go into a new field like that, like the first ever X-ray satellite or the first radio astronomy telescope or something, you discover stuff that you didn't know existed. So we're going to find lots of things that are new and unexpected. But the thing we can be confident doing is producing this exquisite map of how bright things are and where they are. And essentially every major astronomy project for the next 40 years has been built and designed assuming that Gaia works. And so if Gaia hadn't worked, there'd be an awful lot of people having to go to plan B. So it will be underpinning all the next generation of facilities and telescopes and so on, and projects that have been going on. We expect for probably 30 years, by which time we'll have to do another one.
Science, it just keeps on trucking. Jerry Gilmore there, and that website is gaia.ac.uk, so get involved. Note that was an actual astronomer referring to astronomy numbers being stupid and calling my brethren computer nerds. That wasn't me, so please don't write in to complain. BBC Inside Science at bbc.co.uk. Many of us would love to go into space, but almost 60 years after the dawn of the space age, very few, certainly not your average Radio 4 presenter, can afford it. If you've got the money, the options include a return flight to the International Space Station. Tickets are about $50 million. Instead, a seat on Richard Branson's Virgin Galactic space plan. That's much cheaper, only $250,000. But there might soon be a cheaper alternative, as long as you're not too fussy about the definition of what constitutes space. BBC Future space correspondent Richard Hollingham reports from Tucson, Arizona, where a balloon company is planning to fly tourists high into the stratosphere and also take on services provided by satellites with their stratolites.
As we ascend, we will watch the sky turn from blue to black. Once we get up to altitude, we'll be able to see the curvature of the Earth, the thinness of the atmosphere. We'll get to see our sun against a black sky.
Astronaut Ron Garan has spent a total of 177 days in orbit around the Earth, completing 4 spacewalks during his 2 missions to the International Space Station. He's now training to fly high-altitude, helium-filled balloons for Tucson-based company WorldSpace.
Everything I've done since leaving NASA has been done with the idea of sharing a perspective of our planet that I believe has profound positive implications for the trajectory of our global society. The more people I think that have that perspective, that can see our planet as a whole living system, the better off all of us here on the surface are going to be.
The astronaut will command a pressurized gondola carrying 6 passengers 20 miles above the Earth. Fitted with comfy seats and an enormous window, the capsule will boast a bar and Wi-Fi, so passengers can update their status from the upper atmosphere. Although it sounds ambitious, Worldview already has a proven track record. The company flies high-altitude balloons carrying scientific experiments, and Google executive Alan Eustace used its balloon technology to achieve his recent record-breaking parachute jump. Company CEO Jane Pointer showed me around the WorldSpace factory in Tucson.
This facility houses our balloon manufacturing area, so we can see a 540-foot-long table where we will be manufacturing the balloons for our Voyager capsule. And then we have other tables where we also manufacture the balloons for our stratolite systems.
It's like the world's longest wallpaper paste table, with this plastic balloon on it. And the balloon, it's not like a plastic bag, is it?
No, it's an extremely sophisticated bag that is made of polyethylene, but it has all kinds of additions to it that allow us to hold a lighter than air gas as we go up through the atmosphere so that we can float above the atmosphere and carry very massive payloads up to 10,000 pounds.
As well as carrying people, payloads could be anything from scientific sensors, cameras or communication systems. These stratolites will compete directly with satellites at, the company claims, a fraction of the cost.
So when you think about a satellite, it is flying at about 100 miles above the Earth at 17,500 miles an hour. Our stratolites are much lower. They're more like 20 miles above the Earth, and they're going very slowly, like about 100 miles an hour. And we can catch winds going in different directions to stay over an area. So you're not really still, per se, but you can loiter around over an area of interest. So you're really sailing in space.
But is it really space? When it comes to winning your astronaut wings, 20 miles doesn't cut it. The officially recognised boundary is known as the Kármán line, at 62 miles or 100 kilometres. A flight in a Worldview balloon will set you back $75,000. But if you've got the money, and you'll need at least double that, other space tourism options will take you beyond the magic line.
Ignition and liftoff.
Blue Origin is currently testing its reusable rocket system. Revealed to the world in a bombastic corporate video, it's designed to carry tourists in a capsule on a parabolic flight into space.
CC detects separation.
PM confirms separation.
Meanwhile, rivals Virgin Galactic and X-Corp are continuing to develop their space planes, with the promise of flights in the coming years. All 3 companies offer a thrill ride with the experience of being able to float around in weightlessness. Worldview's balloon will be much more sedate, albeit a lot cheaper. It will rise slowly into the sky and descend on a paragliding wing. Editor of Spaceflight magazine, former NASA engineer David Baker, knows which experience he would choose.
I don't quite buy into this business that people are going to be so wowed by the fact that they can go, quote, into space, unquote. They're not going into space. And I can't see going up in a balloon, taking hours and hours to get there, just to sit over a completely cloud-filled sky and told, well, that's the Earth down there, folks. I don't think that's going to do it for anybody, frankly.
So how do you think it compares then to the space plane options? I mean, if you had a choice, if you had the money, which would you think you're going to get the better experience, the better overview, the better sense of what it's like to be an astronaut?
By far the better experience is going to go up into a space plane, because you are going past the Kármán line, you are going there actually into space itself as recognised by all international standards. You're not going to get that staying within the atmosphere in a gondola, and that's where I put my money, if I had it.
But it's the fact that it's not an adrenaline-fuelled thrill ride that might appeal to many. And Worldview isn't the only company looking to exploit balloons over pricey spacecraft and satellites. For astronaut Ron Garan, high-altitude balloons will provide the opportunity for many more people, perhaps influential people, to view a planet without borders or boundaries.
I can literally transport people to the edge of space, where I believe many will have profound transformations in the way they see our world.
That report from Richard Hollingham from Tucson, Arizona. Finally this week, I sometimes lament the fact that my wife frequently falls asleep when we're watching films in the evening. Well, it might be that she is not unusual, and this is a real biological phenomenon, and not due to me insisting on watching The Force Awakens for the 7th time. Men and women do have differences in their biological clocks. Women, on average, are less alert late at night and are far more prone to insomnia than men. We're not sure why these differences exist, largely because women are underrepresented in sleep research. Diane Boivin from McGill University in Montreal has just published research that has specifically attempted to address this historical shortfall. As she explained to me,
women are underrepresented in actual research studies because it requires much more effort to consider the menstrual cycle, which can be a confounding factor, and when you want to control that variable, namely sex itself, which is an important variable, often women are left out of these studies, and we have to extrapolate the results gathered in male to apply them to women, but sometimes it's really inappropriate. So actually the implication guided the research.